So we'll quickly do a few questions related to naming. Just a second, let me. So naming organic compounds. Then we'll just quickly revise this. So first one is, so one thing that I guess which we did cover last time was, we did cover the longest chain part. So starting with these molecules which are in front of me, you've got this one. This is the longest carbon atom chain is 3 carbon atoms. That's the longest carbon atom chain. And there's one, so that's propane. It's an alkane, and this one is a carbon branch, 1 carbon atom. So that's your methyl branch, which is on the second one. So that's 2 methyl propane. So then this one is the longest carbon atom chain. That's 4 carbon atoms. There's 1 carbon atom chain. So this one is a butane molecule, and there are 2 methyls, one over here. So that's dimethyl. And one is at position number 2, the other one is at position number 3. In this one, the longest carbon atom chain is this one. So that's that's 3 and 3, 6. So that's hexane. And there's a methyl. So this is 1, this is 2. It's on the third one. The shortest side, that's 3. So this one is 3 methyl. So we're going to draw these molecules. You've got hexane. So that's 1, 2, 3, 4, 5, and 6. 2 to 4 trimethyl. 2 means the 2 methyls over here. And 1 at the fourth one. So 2 to 4 trimethyl, 3 methyl groups, and the rest are all. So the rest are all hydrogens. 3 methyl but 1-ene. That's what is that? That's but is 4 carbon atoms. 1-ene means that there's a double bond on the first one. And there's 3 methyl, which means on the third one there's a methyl, which is this one will have 1H. This one will have 1H as well. And this one will have 2 H's. So you've got to name this one. That's remember, the main chain has to have the maximum groups, double bonds, etc. So that's going to be your main chain, although it's a shorter one, but that's going to be selected as the main chain. That's but. And it's ene, it's an alkene, and it's a diene because there are 2 double bonds. One is at 1 and the other one is at 3. So it's but 1,3-diene, 1 at double bond at 1, double bond at 3. And you've got this branch, which is 2 carbon atoms. So that's ethyl, which is at position number 2. So this is your main chain. And that over there is your branch. Baki bhi jaldi se kar lete hain. It's pentane, that's 5. 3 methyl means on the third one there's a methyl, 1 carbon atom, and on the second one there's an iodine. And the rest are all, it's an alkane, so there's 1H over here, 3 H's with this one. फिर ये वाला name करना, that's 4 carbon atoms, no branches, so that's but. All, and it's a diol because you got 2 OH groups. One is at position number 1, the other one is at position number 2. So it's butan, and there's an AN as well. I mean, it's a but. It's saturated, that means it's AN. अच्छा, इसका क्या नाम होगा? But what is this thing called?
Ketone.
ठीक है, that's a ketone. It's butan. अच्छा, it's this one is buta. अच्छा, it's butanone and it's double bond
3-methyl.
and it's 3-methyl. ठीक है. Remember, जो higher precedence group होता है, that's going to be given. I mean, this one has to be given the smaller number, so that's why methyl is going to be 3. Now skeletal formulas. ठीक है, we did not do skeletal formulas last time. Skeletal formulas are, okay, what do you do in the skeletal formula? That you just draw the carbon atoms. ठीक है. So you've got so if you have this molecule, so if you have this molecule, what you'll do is you'll just draw you'll just focus on these carbon atoms. Okay, that's your 5 carbon atoms in a line, and then there's this carbon atom, and then there's 2 more carbon atoms over here. So you'll just link up the carbon atoms. That's about it. So the first thing, I'm just going to draw the straight line. That's 5 carbon atoms. So 5 carbon atoms will be, that's 1, 2, 3, 4, and then there's 5. So those are my 5 carbon atoms. And on the second carbon atom, there's another carbon atom. So on the second one, yahan pe there's this other carbon atom. So I've drawn that. And this carbon atom over here, especially this one over here, that's a double bond ONH. So you draw the functional group. Okay, so it's got a double bond. So it's got a double bond O and H. Okay, that's what this is on the second carbon atom. Then on the fourth one, 1, 2, 3, 4, fourth wale pe na, there's the 2 more carbon atoms on the fourth one. So on the fourth one, there are 2 more carbon atoms. So let's draw those 2 more carbon atoms. So it's going to be 1 carbon atom and then another carbon atom. Okay, so there are 2 more carbon atoms. And usme this one over here has an OH. So I'll add that OH. So you draw functional groups. Okay, you draw functional groups. There's a double bond between the third and fourth. So 1, 2, 3, third and fourth. There's a double bond over here. So you got to add that as well. So wo add kar do. Okay, over here there's going to be a double bond. So that's about it. That's the skeletal formula. So I'll try and draw skeletal formulas for, so let's say these molecules. Okay, just for practice, okay, what's a skeletal formula? That so 4 carbon atoms in a line. So I'll just draw that. So kya hoga? 4 carbon atoms. That's 1, 2, 3, and 4. So 1, 2, 3, and 4. That's 4 carbon atoms in a line. On the second one, there's a double bond O. Of the third one, pe there's another carbon atom. Okay, that's this one. So you have third pe, that's this one. Isko draw kar lete. It's again 1, 2, 3, 4 carbon atoms. So that's 1, 2, 3, and 4. Achha, fir OH kis pe? On the first one, there's an OH. So I got an OH over here on the first one.
Sir?
हाँ जी.
सर ये अभी AS का ही चल रहा है ना?
हाँ, बस उसका बस रिवाइज करके फिर आगे चल रहा है. ठीक है. अच्छा, first और second OH. ठीक है. और कोई कर लेते हैं कि this one. Let's try and do this one. 4 carbon atoms in a line. 3, 4. अच्छा, so that's 1, 2, 3, 4. ठीक है. Double bonds on between the first and second and the third and fourth. Second के ऊपर there are 2 more carbon atoms. So that's 1, 2. So on the second one, there are 2 more carbon atoms. So that's the skeletal formula. तो ये थोड़ी सी उसकी practice होगी skeletal formulas की. You're supposed to अच्छा, so these are skeletal formulas, so we can try and name these. What is this molecule? It's 1, 2, 3, 4, 5, 6, 7. That's the longest chain, so that's 7. That's and it's an alkane, so it's heptane. बल्कि heptane नहीं है. There's a double bond O as well, so that's a ketone. So it's heptanone. This is first to 1, 2, 3, 4, 5. ठीक है, the ketone has to be it's 3-one. And there's a carbon branch, one carbon atom branch on the fifth one, so it's 5-methyl. ठीक है. I'd say the longest chain, that's I guess it's 1, 2, 3, 4, 5, 6, 7. That's the longest chain. ठीक है, and you're going to count from this side. कितने हो गए? 7 हो गया फिर से. अच्छा, so it's again it's a ketone, so it's heptanone, or the ketone is at 2, and now there's 2 carbon atom branch on the fifth one. That's ethyl, and that's on the 5th carbon atom, so it's 5-ethyl. I see it is simple. This is 1, 2, 3, 4, 5, 6, 7. Heptane 2 on it. Achha, so over here, this one is also simple, the previous one. Let's do 13, 3, 4, 5 trimethyl heptane. He's asking for the skeletal formula. So we're going to start with heptane. Heptane is 7 carbon atoms. So that's 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5, 6, and then you've got the 7th one. Okay, so 7 carbon atoms, heptane. And it's on the third one, there's an ethyl. So there are 2 carbon atoms on the third one. So that's 2 carbon atoms on the third one. So that's ethyl. And on 2, 4, and 5, there's a trimethyl. So that means 3 methyl groups. 2 ke upar bhi hai. 4 pe bhi hai. There's one at 4 and there's one at 5 as well. So this is what the molecule will look like. That's the skeletal formula of this thing. ठीक है. बाकी बस ठीक है. ये वैसे बस practice करनी थी कि naming just a little bit. We'll just move on now. और एक सेकंड देना, मैं एक चीज खोल लूं. अच्छा, नेमिंग क्लियर है? याद आ गई सारी? It's the same old one. ठीक है. अच्छा, एक सेकंड. Part 1. अच्छा, नेमिंग के बाद सिलेबस. ठीक है, we're done with naming. Let's cover isomers, I guess. ठीक है, let's try and do isomers very quickly. ठीक है, recap all the isomers. So starting with क्या isomers होते हैं? Starting with the first type of isomers. You had structural isomers. That was the first type. ठीक है, so you had structural isomers. So these were same molecular formula, different structures. It's the same molecular formula, different. It's a different structural. It's a different structural formula. What would happen in structural formula का मतलब है कि over here in this case there was a different arrangement of atoms. Now in structural isomerism, the connections were different. And there were three types of structural isomers. The first one was, what's the three types? Like, of structural isomers. Like if they ask you for structural isomers, there are three different types. Does anyone remember how many different types?
Sir, stereo.
Okay, so you had stereo नहीं. Stereo तो structural होते नहीं थे ना. किसी ने बताया था इसे, मैं देख लूं. ठीक है, positional functional, there was another one, branch isomerism or chain isomerism. ठीक है, so there was this other one as well. अच्छा, तो यहाँ पे ना the type of isomer. The first one is chain isomers.
सर वो तीन थे, चेन और ब्रांच और एक उसके साथ वो था क्या कहते हैं पोजिशनल और फंक्शनल ग्रुप आइसोमर्स.
ठीक है, तो पहले chain और branch. ठीक है, chain और branch में what happened was के if I have a molecule, if I have a molecule with let's say 5 carbon atoms, I have an alkane. ठीक है, so there's CH2, there's CH2. And this thing is, again, the reason why is isomerism important? Isomerism is important क्योंकि molecules के बारे में जब आप analyze करते हो, when you analyze a molecule, and you don't, I mean, the structure is never given to you. There's no camera that takes a picture and tells you, okay, this is how the molecule looks like. The first information that you get about a molecule is that it's got 5 carbon atoms and it's got 12 hydrogens. So then you start making a lot of guesswork. Okay, how would the 5 carbon atoms and 12 hydrogens? I mean, that's the first information that you get about any molecule. Like, what's the ratio of the elements of different atoms in a particular molecule? तो उससे फिर आप guesswork शुरू करते हो. You try and figure out so that's why isomers are important, because isomers help you in figuring out what is the exact structure of a molecule. Okay, so analysis winner, that's the first thing that you do. Now C5H12, that could be one version of C5H12. Then you could have some chain isomers, you could have 4 carbon atoms, or you can have a carbon atom over here. So 3 hydrogens, this is 2 hydrogens, this is 1 hydrogen, this is 3. और यहाँ पे भी 3 है. ठीक है, so that's a rearrangement of the chain, of the carbon chain. अच्छा, और फिर आपके पास you could have another one, which is that the 5 carbon atoms could be arranged in this way. And that's still an isomer. So these are the 3 branch isomers. So general idea आपको पता होगा कि that's what branch isomerism is. The second one is positional isomers. So positional is what's a positional isomer? A positional isomer is that you're going to change the position of a certain group. And so you can change the position of a functional group, or usually it's a functional group that you change the position of. So for example, if I have a butene molecule, so the 3 H's, there are 2 H's, this one has 1 H, and they're going to be 2 H's with this one. So there's going to be another version where the position of the functional group or the double bond will be different. So one of them is but-1-ene, the other one is but. So the other one is but-2-ene. Okay, that's. So our concept part C was functional group isomerism. Remember वो अभी भी ये सारी चीजें पूछेंगे आपसे, ठीक है? They'll ask you about this. So functional group isomer. What's a functional group isomer? So you might have an aldehyde and you can have another version of a molecule that could be a ketone. So in this rearrangement, you can change the functional group as well. So propanol and propanone are isomers of each other. They're going to have different properties. So और क्या हो सकता है? A carboxylic acid and an ester, they can be isomers of each other. So the other one could be an ester. An ester has a double bond O and O in the middle. तो एक तरफ आपके पास ester है, the other one is the other one is a carboxylic acid. अच्छा एक सेकंड में नहीं है. So the other one can be a carboxylic. और इस तरह बहुत सारे हैं, ठीक है? A lot of functional groups can be isomers of each other. Alkanes and alkenes can be isomers. For example, you might have so you can have an alkene, 1H, and this one will have 3 H's. And you can have a cycloalkane that so one of them is an alkene, the other one is the other one is a cycloalkane. ठीक है, they can be isomers of each other. But that's about it. ठीक है, तो ये 3 types के ना आपके पास you've got structural isomers. ठीक है, clear है सारों को? तो अच्छा आगे मूव कर जाते हैं, which is the other one, which is क्या था इसके बाद? It was stereoisomerism. ठीक है, so stereoisomers were isomers. So these were isomers where you had same molecular formula, but you had the same structural formula as well. So you had the same molecular formula and you had the same structural formula, but you had a different three-dimensional geometry of the molecule. So different three-dimensional geometry of the molecule. ये बस geometry लिख देते हैं. अच्छा, और different orientation of bonds in space, और वो एक देख लेते हैं कि you can definitely तो छोड़ो इसे, ये ठीक है. अच्छा, different three-dimensional geometry. And कितने types के, how many different types of stereoisomers did you have? So you had, so you had two optical and geometric, ठीक है. So you had, let's start with geometric. Geometric, and then what you had was, actually we did geometric isomers in transition metals as well. Now geometric were that you had, क्या होता था geometric में कि you had you need a double bond, that's the first thing. Or second जो चीज थी ना, that was that each carbon atom must be bonded to a different group. Must be bonded to two different groups. ठीक है, they got to be bonded to two different groups. So this situation थी कि if you had a double bond, then the carbon in the double bond must be bonded to two different, it must be bonded to two different groups. As it must be bonded to two different groups. For example, you might have H over here, and you will have Cl over here, and you will have H over here, and you will have Cl over here. और फिर इसकी ना एक और version होगी, which is कि you'll have another version. अच्छा, in that other version, जो molecule होगा in this other version, one side will be flipped around. The Cl over here will be on the top, and the H will be at the bottom. So this is what's going to happen. Or इसमें, why would that happen? What's the reason for that? So why would this? तो CLs दोनों same side or CLs दोनों opposite side? So you had one which was cis, the other one which was trans. And you had a trans version. And the reason the geometric isomerism happened was, उसकी reason जो थी, that was कि rotation is not possible around a pi bond. So these molecules, they have a pi bond. Okay, what is going on is, okay, the orbitals are overlapping above and below. So rotation is not possible when you have a pi bond. And there's a pi bond on the other one as well. So उधर भी same issue है. Okay, so whenever you have a double bond, rotation is restricted. You can't twist a molecule around. There's so no rotation happens, or rotation is restricted around a double bond. तो pi bond. ठीक है, उसके अगर rotation is not possible. So that's what a geometric isomer is. We'll just do a couple of examples. Okay, I've got. So you can't. So we'll do a couple of examples. Let's say I've got. So let's say I've got this molecule with the double bond and there's carbon atom, and then so there's another double bond and a Cl, and there's H. So इसमें से बताओ कि which one, around which double bond will left one or right one, which one will have geometric isomerism?
Right one.
ठीक है, so it's ठीक है, right one. It's going to be the right one because ये जो पहला वाला double bond है ना, उसके तो दोनों जो groups है ना, they're exactly the same. I mean, you've got a CH3 and you've got another CH3. ठीक है, this is not the three-dimensional shape, but for stereoisomerism to happen, groups different होने चाहिए. ठीक है, तो it's going to happen with the right one. ठीक है, right one में there's this double bond and both groups are different on both sides. कि इसमें अगर आप ना वो ग्रुप को देखोगे ना कि this is H, you've got a Cl. Over here the two groups are different. You've got an H and you've got this whole thing. ठीक है, तो this one will have, the first one will not have, the second one is going to have, it is going to have stereoisomerism. ठीक है, ये वाला होगा और ये वाला नहीं होगा. ठीक है, this one will exist in its three-dimensional shapes. There would be two of them. There's going to be a cis version and there's going to be a trans version. If somebody is going to ask you to draw that, then it's going to look like this. Okay, you'll have a double bond. तो उसके एक साइड पे there's an H and there's a Cl. अच्छा, दूसरी साइड पे it's got two things attached. It's got on one side it's got an H. On one side it's got this whole thing attached, which is what CH. फिर double bond CH है, फिर double bond है, and then there is C, and then there is two CH3 branches. ठीक है, so that's one version of the molecule, and then there's going to be another version of the same molecule, which is going to be, ये वाली कौन सी version है, cis or trans? Left वाली. ये क्या चीज है, cis or trans? ठीक है, this one is, अच्छा this one ठीक है, this is cis. Both of them are actually cis. The trans one is going to be that the positions, the H will be pointing downwards and the Cl will be pointing upwards. तो यहाँ पे जो groups are pointing in the opposite direction, the groups are pointing in the same direction. So this one is cis. And that one is, so that one is trans. There's another thing about geometric isomerism is that a molecule can have multiple, if you have multiple cis and trans, like if you have multiple double bonds that are forming cis and trans, okay? So remember this, that in unsymmetric, molecules, if you have n double bonds and all of them are making cis trans, so if you have an unsymmetric molecule and there is unsymmetric का मतलब है कि it's the left and right side are not exactly the same. So if you have an unsymmetric molecule and there are n double bonds, all of them are making cis trans. So आपके पास at the end of the day you'll have a total of 2 to the power n cis trans molecules. You're going to have 2 to the power n geometric isomers. Like for example, if a molecule has 2 double bonds, then it's going to have 4. Okay, as an example, if I have this molecule, or the first double bond is also making cis trans and the second one is also making cis trans. अच्छा, इस मॉलिक्यूल में इस मॉलिक्यूल में both of them are making cis trans. ठीक है, this one and also this one. So total three-dimensional shapes would be 4. It's going to be 2 to the power 2, and that will give you 4. So you're going to have 4 combinations, which is that either both of them are cis, या फिर both of them are trans, or one of them is cis and the other one is trans, or the first one is trans and the second one is cis. ठीक है, और अगर 3 होता तो you would have 8. ठीक है, symmetric में ना वो कम हो जाता, left right switch. Symmetric में left and right are the same, so cis and trans and cis would be exactly the same. चलो ये clear है? अच्छा बस ठीक है, यहीं पे छोड़ देते हैं. We'll continue tomorrow then. उससे कल probably नहीं, we have to go till alkenes. मेरे ख्याल से we'll take 1 or 2 classes just to get till alkenes. फिर we'll switch to A2. ठीक है, that's when we make the transition towards A2. alkene से linked होगा उसका benzene का, तो वो फिर तब start करते हैं. तो कल बस जल्दी से optical isomers and then we'll try and cover alkanes and alkenes very quickly or revise them. चलो ठीक है, कल बात होती है. ठीक है, so okay everyone, take care, Allah Hafiz.